My name's Ken Bagstead, and I'm going to be speaking today about the application of a tool called ARIES for the development of rapid and more credible ecosystem accounts under the System of Environmental Economic Accounting. So the SEEA, as it's called for those who aren't familiar with it, is a UN-developed system that's designed to give a fully comprehensive view of the extent, condition, and the services provided by ecosystems in both physical and monetary terms. Critically, it's coherent with the system of national accounts, which is another UN-designed system for tracking economic activity and accounts consistently across the world. It's also connected to many of the other key global initiatives mentioned here. However, one of the key limitations in applying SEEA at a really large scale thus far has been its heavy spatial modeling component. So this is very time and data intensive and requires quite a bit of expertise. So if we're to take the long view of the development of global ecosystem accounts and other geospatial modeling, we can see that we've definitely made progress over, say, the last 8 years since the SEEA was first developed. However, the independent compilation, use, and institutionalization of accounts everywhere in the world is a target that we haven't reached. And this is an admittedly high bar. But if we look to the future, based on our past experience, we can continue to make progress toward this goal, but I would argue we're still a fair ways off from it. And one of our interests with this tool called ARIES is to develop an approach that can really get us there much faster. So there's been an assumption in ecosystem service modeling, but I think in most geospatial modeling approaches that these are painstakingly slow approaches that take a lot of time, money, and expertise. The conventional model is to throw a lot of money and time at a problem, to have a GIS analyst and other experts working away and developing either your accounts or the results of your other models, and ultimately, hopefully, putting their results in a data repository. So there's an assumption that we can't have accounts that are high quality and quick and relatively inexpensive. However, with new technology and approaches from the semantic web, I would argue that this is no longer the case. And if we can more successfully and on a larger scale have experts contributing their knowledge, data, and models to the semantic web, which is a collection of linked online resources that a computer system can automatically access and integrate, we should be able to do all this in a much faster and cheaper way. So this is what ARIES is all about, and we'll hear a lot from many approaches that use machine learning and specifically neural networks and deep learning. Some of these areas of AI have been really heavily used and have made some real breakthroughs in recent years, but I'm going to talk about an area that may be less familiar called semantics and machine reasoning, which is really the guts of this system and is another key AI tool. In fact, some of the leaders in AI for scientific modeling argue that semantics are actually the key tool because what they do is they provide a consistent language for computers to understand and recognize data and model elements. And without these, we can't hope to have computers automatically assembling and reusing data and models on their own. So what ARIES does is it takes a series of what's called reasoning algorithms and decision rules that are designed to provide a computer with a way to make decisions about how to assemble data and models. We have open data and models that have semantics that work in a multidisciplinary manner with these reasoning algorithms and the open source software to support them. And what that all enables is ideally fast, fair, and multidisciplinary modeling. And fair in this case refers to findable, accessible, interoperable, and reusable data, which is pretty much the gold standard these days for modern data science, but for which the interoperability and reusability, especially in an automated way by computers, has so far eluded us. So with the coming together of these two worlds, the AI and machine reasoning and the SEEA EEA, our aim is to be able to produce rapid and standardized ecosystem accounts. So we want to support the adoption of the SEEA EEA as a statistical standard by providing a faster and better way to do this anywhere on Earth, even in data scarce countries or countries that don't have a lot of technical expertise. And we do this by providing a set of global models that run on global data and that can be run easily anywhere in the world, but also a way to more quickly and easily customize them wherever we have better local data. So it's global, but it's also automatically customizable. There's an automation of the production of maps and accounting tables as part of this, and this is a project that just began earlier this year, but which we're rapidly ramping up. So the aim here really is to produce a global knowledge network for ecosystem service data and models, and these are the data and models that could underlie a lot of other geospatial modeling approaches beyond ecosystem services as well. But essentially what we have is global data and models that could run anywhere on Earth. We have time series data that go back to 2000 or even earlier, and then the ability, as I said, to replace global data by local data wherever possible. ARIES for SEEA EEA has a custom web interface, so the user, when they're running the application, will pop open their web browser and automatically be able to select which accounts they want to compile, which indicators they want to compile, and how they want to aggregate those. Also, what years they want to compile the accounts across. And the system will go out onto the web, search for the needed data and models, and run them and return the results for the user, all in an automated fashion. So as a few quick examples of this, we have ways to model ecosystem extent using some of IUCN's most recent work on global ecosystem types. This is a very new approach, so there aren't any standardized global maps yet, but we've coded in 25 of the different ecosystem types using global models, and these can, as before, be replaced with local land cover data sets. We can also use annual or multi-year land cover change data to look at how ecosystems are changing over time. And this is an example of the ARIES web browser where we've run a model of ecosystem extent for Nepal, a fairly data scarce place, using global data. And we completed the estimate in about a minute. Similarly, we can examine ecosystem condition, and this is a standard method that's being developed to look at forest ecosystem condition. In this case, pulling down NDVI data off the web, which has to do with forest greenness, comparing that to NDVI in protected areas, and mapping out the condition of forest in a quartile method. And as before, this is done in minutes on a web browser using cloud-based data, and it can be done anywhere on Earth. Finally, we model ecosystem service supply and use, and these are some quick examples of modeling and mapping carbon storage and sediment regulation. We have other services as well. And of course, when a system is automating all these processes and using artificial intelligence to do so, it's important that we're able to very transparently report on what choices were made along the way. And so ARIES includes a data flow diagram, which I show here, where we can see the different steps in the processing pipeline. And when you click on any of these, you get information about the underlying data sets that were used, information about the algorithms that were used at each step of the process. And in addition, ARIES also produces an automated report, which shows the methods, a description of what's been calculated, the results, and any caveats associated with it. So there's a high degree of transparency that goes along with this automation and describes what choices were made and why. Finally, thinking toward the future, we're continuing to expand this work for supporting ecosystem accounting on the UN Global Platform. But there's quite a few features included in ARIES already, including the ingestion of remote sensing data, the ability for experts to contribute data and models, but also for non-technical users to use and gain from the system, and the integration of a whole variety of modeling paradigms into one sort of overarching linkable system. There are a number of possible applications that you can think of beyond ecosystem accounting that this could also support. And for those who are interested, I'm happy to talk more about those. And you can find more information about the project here, as well as some contact information below. And I think the key question with all of this is making the global community aware of the benefits of fully fair, findable, accessible, interoperable, and reusable data and models, and asking how willing are we to change our habits with data and model storage in order to achieve these benefits. And I hope I've shown some of those benefits today, and that we're able to progress as a community using AI in a smarter way to integrate data and models in support of global goals. Thank you so much.